So this is what shows up when I open the PhET simulation for the collisions. So I'm going to reduce the mass of these billiard balls as much as I can. I'm going to show more data, and the position here really doesn't matter a whole lot. However, this one here I'd like to place at -0.1, and the velocity of the second one ought to be 0. There we go. Nope. Here we go. So it's at rest. And then the other one only has a velocity in the horizontal. And it already gives us the data. So the mass of both of them is 0.1 kilograms. So billiard balls, of course, are of the same mass. And again, the position really doesn't matter except this one right here, so that the cue ball can hit off center and we get kind of like an angle. In fact, here it is. There you go, just like we would expect, right? So let's look at the numbers. So both of them have a mass of 0.1 that is multiplied by the velocity. So 0.1 times 1 is the 0.1. That's the total momentum before, and it's only in the x direction because nothing happens in the y direction. And of course, the momentum for the pink, I guess, number 2 ball is 0 anyway. So I'm going to run it. So remember this 0.1 here, that's the total momentum, just on the x. And then the y, it's 0 between the two. Okay, here we go. And then when we read that off now, respectively, when we multiply 0.1 times 0.032 and 0.1 times 0.68, we come up with these numbers here, 0.032, 0.068. I know they round them here. And in any case, these two add up to the original 0.1 kilograms meters per second, the original momentum. And when we do that in the y direction, then here we have 0.1 times 0.47, 0.1 times -0.47, and we come up with this momentum. And when we add them up, we come up with 0. No, one positive, the other one negative, just like it was before. So momentum is being conserved in this collision. Of course, this is frictionless here. There is also the elasticity is actually 100% here, and this is a perfect applet, so to say. So here's with 3 billiard balls as I added this one in. I already tested it to my liking. And again, the position here doesn't really matter, except I place them in such a way that when they actually collide, here we go, they actually kind of spread out nicely. And again, they do exactly what we expect them to do. Now let's look at the momentum. Again, the cue ball here, that I guess bluish turquoise one, is 0.1 times 1. So we come up with momentum 0.1 overall in the x direction. That's the only momentum we have. And then the y direction is 0. Both of them after the collision are being conserved. So again, we're going to hit this one here and pause. And obviously we notice that one is going up and to the left. Hence we have these kinds of velocities for the blue one. For the pink one, it's going to the right and down. So we have these kinds of velocities here. And for the sort of purple or violet, it goes right and up. And so we have these kinds of velocities. And again, if you multiply the mass, each mass, by each x velocity, you come up with this. And when you add these carefully, you come up with the original 0.1 kilogram meters per second. And when you add, when you multiply these masses, each one of them with the y direction, with the y velocity, you come up with these numbers. And again, if you carefully add them up, you come up with 0.00 kilograms meters per second, which was the original momentum. So again, it's a perfect applet. Friction is turned off. So we could almost expect that we come up with perfect results for this one. In the actual experiment, of course, that won't be the case.